multi implementations, in this case Janus and WebRTC, to take advantage of the strongest points of both. So Janus has a good SFU, FreeSWITCH has a very good MCU, and so how you can actually take advantage of both in a WebRTC application to do cool things. And Giacomo will describe a bit how you can do this in practice. So enjoy, and please, Giacomo.
Thanks.
Go ahead. Thank you.
So this, as Lorenzo mentioned, this can be seen as a sort of in between a presentation and a workshop. So the idea is to present in the approach and see a little details about Janus, in particular with the video room. Since it's possible that from the very back of the room the slides are not very visible, so I put the slides already online, and there is a tiny URL, so if you want to get that one and follow the slides while I talk, you can do that. I'll put it back. So why Janus and FreeSWITCH? Because so they are open source projects, they are very successful and they are well known, and they have one characteristics each that was interested in my work, and one is related to FreeSWITCH as an MCU, and the other as Janus as an implementation of SFU in the video room plugin. So about Nexmo was brought me here and also sponsoring the social event this evening. So you can see Nexmo, the easiest way is to see it as a CPaaS, so a communication platform as a service. In particular, I take care of the SIP stack. So the SIP stack is responsible for interconnecting the voice APIs with the PSTN carriers and with the SIP users. The platform allows you to define your own application with your defined behavior, and then you can connect your application with a PSTN number or with the SIP URI. So whoever dials that number basically is enters into the application, and whatever you have programmed will be executed. It could be connecting to another number, it could be playing a message, and so on. So you can build your own service on top of Nexmo's APIs. So the stack is built when possible on top of open source applications like Camellio and Asterisk. Of course, there's NGNX and FreeSWITCH for what concerns conferencing and recording. And also we use Epic, which is a version of Homer that also provides us with real-time quality of service information. So each call is visible in a Homer-like flow, and together with the SIP signaling, there's also quality of service as analyzed on the wire. So in terms of this presentation, in my opinion, there are three big integration points. There are related to WebRTC and SIP on one side, and then there's the SFU and the MCU approach on the other, and of course the two other components, which are Janus and FreeSWITCH. Just a few words about me. So I started working in VoIP in 2001, and unfortunately I have a negative story in terms of PhDs, because I dropped mine to follow a small startup that was operating in my hometown, and I didn't complete my PhD for this reason. And but it was interesting because it was the pre-SIP protocol era. We started with a custom protocol and H323, and then moved to SIP later on. And then I moved into the UK to work with Truphone when we were few, probably just about 20 people. And then I could work with Federico in Le Bon Orange in Paris, and currently I'm working in Nexmo. And I think I'm mostly a promoter of open source and a user, and use it whenever possible to design and build solutions. So there is a coupon code. So if you want to try to um, create an account with Nexmo, use that coupon. There's 10 euros in there. It's enough to um, try the service, build your own application, buy a DID number, and link the application to your number, and you can play with it and get more familiar with you if you want. Of course, we are hiring, in particular in the area around Camaillo and RTP engine. So if you're interested, feel free to come and talk to me. So why combining MCU and SFU? Of course, you know that MCU is heavier from the computational point of view, but provides more features on the server side. So it's suitable for let's call them less intelligent clients, or clients with limited bandwidth or capacity of managing streams, like mobile clients, at least as it was in before WebRTC. And SFU, of course, it's lighter from the computational point of view because it's a sort of routing of streams, and but at the same time allows more freedom on the client side. So clients can be more clever and creative and composing the streams in any way they want. So I figured Janus was the topic of the conference, so I would focus a little bit more on FreeSWITCH in this introduction. And so there are two main components that are used in the proof of concept. One is the mod conference, which is in fact the module working as the MCU, and mod verto, which is verto is a custom protocol that they designed, which allows you to bypass basically SIP for signaling, and it's a very lightweight JSON-based protocol where basically you exchange STP, and it's sort of you can use it for your WebRTC clients. Of course, once you are using an MCU, you have one very easy to manage single stream for each client. So in particular for the simplest mobile clients, it's easy to get the entire conference basically on one single incoming stream. And it's basically on the client side is managed as if it was a one-to-one call. And another typical usage of FreeSWITCH, as you probably know already, is as a sort of gateway or interface between SIP clients and other clients and PSTN, which is for the majority still managed with SIP interconnections. So there are a few interesting features in mod conference related also to recording, and in Nexmo we do separate multi-stream recording, so each stream is recorded separately. There's for what concerns video, there's canvas composition. There are different layouts that you can select for composing your video, and of course since there's support for Opus, there's also the possibility to do Opus at high quality, 48 kilohertz, but also to do interconnection with PSTN, doing transcoding, so transcode between PSTN and G711. So a link to, you will see probably in the slide. In the slides, I linked something related to the study we were doing in relation to how Opus can be negotiated, how it can be asymmetric, and in particular how it can be low quality, or well, let's say the same quality as G711 by using the 8 kilohertz sampling option. And we'll see also for the workshop, we'll see how we can play with the streams with a command that is relate, which is applied to a conference room and allows us to manage where the stream go among the participants. And of course, if you have FreeSWITCH in place, then you can connect SIP endpoints. You can interact with PSTN gateways. But if you want, you can also connect directly WebRTC clients, because they can just use the verto protocol. and you can also connect them via WebSocket. For example, in Nexmo we have a service which is provided by WebSocket, where the system interconnects to WebSocket providers for stuff like automatic audio recognition and so on. I think there is another link on the role of Opus in FreeSWITCH in the slide. So for this specific proof of concept, so there will be SIP and verto in play in FreeSWITCH. And as I mentioned, so verto is a very simple protocol. It has invite, answer, and buy basically, and it's JSON based, and it just serves the purpose of transferring the SDP from FreeSWITCH to another entity. And I think I saw a presentation in KluCon this year by Julian Cheventon, who reminded me that already 5 years ago, at that time I was in Trufon, we were using FreeSWITCH together with Camaillo for starting providing a WebRTC service, and it was very nice to see Camaillo in front of it with working as a WebSocket server and doing ephemeral authentication, and on the media server side, FreeSWITCH doing interacting with at that time it was a JS-SIP client, and we chose it because we were so familiar with SIP that we were less scared of using it instead of moving to a brand new WebRTC protocol. And there is a link to a great documentation of the verto protocol. I found it very useful, so I put it in the references. So about Janus in particular, about the video room plugin, which is the one implementing the SFU. So basically the SFU, I think it's RFC 7667, which provides a few RTP topologies. One of these is this selective forwarding middle box or selective forwarding unit, and it's a lightweight router of streams basically, and it works as a subscriber publisher pattern. So each component can be a publisher of a feed and a subscriber of one or more feed, but also it can be also only subscriber or subscribing to only one or two, and can be combined in a flexible way. So the main operations from a client point of view is to create a transaction attached to the video plugin, so that you get a handle as a publisher and then a separate handle as a subscriber. And then you will need to join the room, and again you will need to decide whether you are the publisher or a subscriber to that room. And then you will configure media, so that basically the session negotiation that will have to happen between the client and Janus. So the slides are a bit so the drawings are a little bit naive, but I thought I was trying to privilege visibility rather than precision. But anyway, so the main concept is that I developed a small controller application in Node.js, and this one, the role is to connect to FreeSWITCH and to Janus, and to orchestrate the conferencing scenario. So it connects to FreeSWITCH as in two different ways. One, via WebSocket as a verto client, and then it connects to the ESL, which is the event socket layer in FreeSWITCH, which is a sort of API and event interface, simply via TCP. And then it connects to the REST API of Janus via a simple HTTP connection. I guess the ideal in a production system would be to use WebSocket and keep this WebSocket open and get the events without doing the polling. And between the two, there will be at some point a DTLS SRTP exchange of media. And in this case, the WebRTC clients will connect to Janus and also to a web server to get the demo application, and the SIP client will connect to FreeSWITCH. As I mentioned, so the control application is written in Node.js just because it's easy. I'm not a Node.js developer, so probably for doing anything serious going on production, it would need to be rewritten. At the same time, there are many client libraries that can be used, and they are published in that link, so you can select one depending on your technology of choice. For example, Luca tomorrow will present their own solution, and that's Python based, and there will be some similarities, a few differences. And so I wanted to animate this one because I'm not sure how clear otherwise it would have been. But anyway, so this is the scenario where we have a WebRTC client joining a video room in Janus and publishing their stream into the room, and another WebRTC client subscribing as a subscriber of that stream, but also becoming a publisher of their own, and in turn C becomes a subscriber to D. So this is a very simple scenario where there are two people in the video room in the demo application in what you probably already know. So the difference is when there is a SIP client that joins FreeSWITCH. In this case, the call is routed via dial plan and a Lua script into a conference room, and FreeSWITCH, in this case, through the controller application, becomes a subscriber to the WebRTC streams. It becomes a subscriber because the controller application knows that there is a list of participants, and on behalf of FreeSWITch subscribes. So basically it makes FreeSWITch becoming a subscriber to those streams. And at the same time, so in these two streams arrive into the mixer inside a mod conference room, and they are provided to the SIP client in a mixed fashion. At the same time, the stream that is produced by the SIP client is then provided. In this case, FreeSWITch works as a publisher, and does the attach does the join and becomes a publisher, and this is then routed to both C and D. So in this case, we have a client joining the video room. The interesting part is that we are still able to do specific stuff to the two streams C and D that are arriving into FreeSWITch. So if we want to change them in any way, if we want to record them, they are separate and they can be treated still as separate, even though they are inside a mixing room. So just to make it a little bit more complex, there is a client B will join the same instance. You can imagine any type of system to make it join the proper instance. In this case, the mixer in mod conference will start mixing also A and B, and will send it towards Janus in the stream that is already being published, and it will be then made available to C and D in the stream that they have already been subscribed to. And at the same time, A will receive also B mixed in, and B will receive the mix of A and C and D inside the single stream that it will receive. So this is a little bit more detailed in how FreeSWITch becomes a publisher when it needs to, and so basically there is a SIP invite. FreeSWITch accepts it and put it in a conference, and there is already exchange of RTP between the two. But then FreeSWITch generates towards the controller a verto invite, which carries the SDP of FreeSWITch for the room, and the controller basically initiates on behalf of FreeSWITch the negotiation for becoming a publisher. So it creates a transaction, attaches to the plugin, and offers the SDP from FreeSWITch to Janus. Janus says, of course you can become a publisher. This is my SDP, so you can publish your streams negotiating the session in this way, um, and this will become a verto answer with the same SDP towards FreeSWITCH. In this case, FreeSWITCH will initiate the ICE negotiation and will instantiate the TLS session, and then will publish the TLS SRTP as publisher into the Janus video room. This is, of course, is not readable in the audience, but it's there in the slides for later. These are the details of the negotiation. It's the same as I just shown with more details. I think the two key components are that when FreeSWITCH wants to become a publisher, it will specify in the SDP the send-only attribute. And the other particular or interesting thing is that it will need to set trickle to false inside the JSEP. So the JSEP is the structure carrying the SDP. Trickle false because FreeSWITCH won't be able to gather more ICE candidates. So basically, it knows already that all the candidates are there, and it's telling Janus, I'm finished already with the candidates. Don't expect more. And this will make the negotiation quicker. It's similar in terms of FreeSWITCH becoming a subscriber. In this case, without details on how a WebRTC clients become a publisher, Janus will provide the list of publishers to the controller application via the API, and so the controller can apply some logic and saying, okay, there are some new publishers FreeSWITCH is not subscribed to, so I'm going to become a subscriber on behalf of FreeSWITCH. So it attaches and joins the room, and as an event it will get from Janus the SDP for this other session, and this will be translated into a verto invite with that SDP to FreeSWITCH, which will answer with its own SDP, which is then will be provided in the start room request to Janus. In this case, it will be Janus probing, doing the stand binding request, and verifying the ICE, basically instantiate the DTLS session, and sending the flow from C to FreeSWITCH via DTLS SRTP. Again, for the sake of details only visible in the slides, in this case the offer would be receive only from FreeSWITCH because it wants just to become a subscriber, and trickle false applies in the same way. So if I can go back here, so you notice that the gray arrow from FreeSWITCH to Janus only contains A and B. So theoretically, if this was a normal mixer in a conference, this would have A, B, and D for C, and A, B, and C for D, because it would have all the streams to one participant apart from the participants itself. In this case, we don't want to send the audio from C to D because we know that D is already receiving the audio directly from C, from the SFU. So this is where, through the API in FreeSWITCH, we tell FreeSWITCH, well, you know, the audio from C, don't send it as a publisher, because the audio from C will be received directly through Janus, so it's not necessary. This is why I called it the prestidigitation, because it's the part that requires a little bit of more manipulation. So this is a function which is called relate, provided by FreeSWITCH's mod conference, and it allows you to control which how to direct the streams. So, well, just to show you, this is a normal the video room in the demo, in the normal master Janus repo. We were testing with Federico with some quizzical faces perhaps, but we were happy doing this test. And just to show that, so we had one normal video, two normal WebRTC clients connected, and then a third one without video, which was with the soft fonts coming from FreeSWITCH. But also, and by the way, I published this code, so you can see there's the controller application. As I said, Node.js, not the most beautiful implementation you will ever see. It's a way of showing how the negotiation needs to be done and how the events need to be managed. And so I wanted to do the demo and see if I can show you, because I have a few minutes. Nothing of this is visible. So I'm going to start the FreeSWITCH. I'm not sure I have. Okay, so let me regain access. So I'm going to start the FreeSWITCH instance. Here, and then once it's ready, I will just load modverto and mod conference, and we'll start the controller application. So meanwhile, I can start Janus in another. So these are just two tiny DigitalOcean boxes. So one hosting FreeSWITCH and the other one hosting Janus. So in this one, I'm going to start the controller. Okay, well, modverto is not loaded yet, so let me load modverto and mod conference. Like this. Then I will attach the controller application this way, and in the browser I can have for example one window here. Can reload this. Okay, let me start also the web server. Okay, and then I can reload this. Maybe, yes. So just I entered the room as a normal WebRTC client, and then say I got an incognito on window, and I join as well. Like this, and then with LinkPhone I dial into just a number that I set to connect to make FreeSWITCH become a publisher, and connect there, and then I've got the FreeSWITCH joining in, and then I can also join with another client, dial in the same number. It will just be connected inside the same room. I figured showing the audio wasn't going to be easy anyway in the demo, so I didn't bother that much. But this is the configuration that I presented. And that's it. So very quickly, the end of the presentation. So can this be achieved in a different way? This is true. This is of course. So you can have a more pure approach. You can have an SFU solution on FreeSWITCH, or you can have the MCU, or everything basically built on Janus. It will probably be more cohesive, more performant, more efficient. I think this approach of system integration instead is probably quicker, can get you there faster, and it probably has less risks in terms of development. Performance, scalability, and web browser compatibility was not the scope in the scope of the proof of concept. Probably the scalability can be achieved separately. So FreeSWITCH will scale as usual as a farm or as a cluster, and in parallel Janus will scale as a cluster or in cascading mode separately, and this probably is another advantage for system integration. And the dial plan wasn't dynamic. The rooms weren't created dynamically during the POC. So this is all limitations of the proof of concept. So the final thing is, I think the purpose of the presentation was that Janus and FreeSWITCH can interoperate in this scenario, and it can be one solution that you have it in your set of possible solutions for what you are designing and want to do. A few references, you will have them in the slides, including the book from Giovanni about FreeSWITCH 1.8, and that's it.
Thank you. I think we have time for one question. So does anybody have a question for Giacomo? I see Mirko.
Hi, and thanks for the talk. I was just wondering, do you experience the delay in audio setup and media setup, basically? Because I have the same problem, and I'm starting to implement the trickling in FreeSWITCH, or at least in our custom model.
So for the specific thing I was doing, there is a little bit of delay before the WebRTC app event is available. Yes. But in terms of the speed of interconnection, this is exactly why I used trickle false. That proved to be the quickest way to have the streams set up.
Thanks again, Giacomo. It was an impressive
No problem.
presentation. So
Thank you.
thanks.